Okay, so this is our Raspberry module, and this is our temperature sensor and our GPS sensor, and that's the LoRa that has been connected. So now, for now, there has been some issues in detecting our LoRa. I guess like there is some problem with the device, but it will be sorted out with the drivers. But so we have connected with the Wi-Fi, and then we are connecting with the server. The server is locally hosted in the computer, and this is like, so I'm inside the Raspberry Pi, and I'm running the program which is detecting the temperature. And not only is detecting the temperature, like it's also this Raspberry Pi is also sending to the server also. So like, this is inside the Raspberry Pi. This is just an SSH way, but this is how we are interacting in a blockchain way. And as we can see, like this is like, as you can see, our uh, package with ID 5469. This is the package part, and with ID 5469 we are getting a temperature reading that's 22 degrees Celsius currently. So let's just reload it, and then like that's the business one. And that's my, so like we have manufacturer, retailer, shipper, wholesale person, and packages. Packages are the shipments that are and Raspberry Pi is automatically doing transactions with the package temperature transactions. And like we can see all, like the temperature is being saved with a timestamp, a transaction ID. It is being saved in the blockchain. So like we can just detect that at this time we had in this, with this transaction ID, the temperature was 22. We are correcting the mean temperature for a delay of 5 seconds. So that's it. Like we're storing it in the blockchain, and that's it. So we have a DHT sensor, we have a GPS. Yeah, GPS also is being coded here, and that's our LoRa that has been connected, but still we are having some driver issues.
Okay, so now we come to the pharmaceutical supply chain network. So there are 4 participants in this network. One is a manufacturer. The work of the manufacturer is to enter the details of medicine batch into the main blockchain network. The network administrator verifies the batch and then successfully confirms the addition of batch data to the network. Then the another participant is the shipper. The work of shipper is first is to provide the basic logistics to the medicine or vaccine batch. The other is to create a dynamic contract which will involve all the participants working in that particular transmission of medicine, and which will be time stamped so it secures it, and it is associated with the package ID of the medicine or vaccine. So the shipper invokes that contract, the network administrator endorses it and gives it back to the shipper for further use, so that other participants can also give their ID into the contract. The third participant is a wholesale person. The wholesale person stores medicine batch with it and keeps it until a retailer arrives and takes that medicine batch from him or her. So wholesale person gives his or her ID to the network administrator, which he verifies or she verifies and then gives the status to the wholesale person. The last participant is a retailer, whose work is to give the medicine, and it also creates a new contract called the end contract in our code, which is associated with the first contract which has been uh, which has been created into by the shipper, and it is the both contract IDs are associated, so the network administrator checks it when the retailer invokes the end contract, and then it gives back the confirmation status.
This is the setup for the GPS module and the temperature sensor. Here we are extracting the location and temperature values using the Raspberry Pi and pushing it to Composer.
Okay, so we are going into the blockchain network channel, which is being hosted locally, and it's working on the technology blockchain 3.0 developed by IBM, called the Hyperledger Composer. Okay, so yeah, here you can see the model file. Let me show you. In the model file, his namespace ID. This is the concept, the address, which includes the state name, the city name, and the zip code for a particular participant, like the manufacturer, the retailer, the shipper, or the wholesale person. These are the transactions which are invoked by a particular participant in order to create some value or to give some value. For example, in this transaction, we are giving the ownership of a particular batch of medicine or vaccine to the shipper from the manufacturer. In this transaction, we are giving the ownership to the wholesale person, and in this transaction, we are giving it to the retailer person. Note that we are calling here a make contract start, which creates a contract, dynamic contract, which goes on till the wholesale, and then the retailer creates a new contract and contract, which gets associated to the make contract, and it can only be successfully invoked if it has been verified by the network administrator. This is a temperature reading transaction which will be invoked by the IoT devices, and it will keep invoking at a particular time interval to send the temperature data to associate with the batch of medicine or vaccine. These are for creating a new participant or slash asset into the blockchain network. This is a particular uh, type and all the information associated with a particular batch of a medicine or vaccine. So here is a batch ID, the particular batch ID created by the manufacturer. This is shipment ID, the ID of the shipment mode, like the ID of a truck or something like that, which gets associated with the batch of the medicine. This is an optional variable called expiry date, which invokes the expiry date of the medicine or the batch of all the medicines. Then there's a unicorn, the how many medicines or vaccines are there in a particular batch in a particular box. There's a mean temperature, the manufactured data of the temperature, which should be there with the medicine all the time, has been prescribed. Then there's a reading, all the readings that has been given by the sensors and pushed by the RPI. Then here's the owner ID. This owner ID designates the current ownership of the package, whereas this owner shows that who by whom this batch has been manufactured. So there are two owner IDs here. One is with the manufacturer, which will always be present with the batch. Another is the ownership, shows the ownership of the batch, that who possess the medicines at the moment. Then there is a contract. Contract includes all the participants, the asset package, and its a status, whether it has been shipped, it has been wholesale, or it is in retailer store, and as well as the contract ID. Now it has been time stamped with the date and time variable, and in the end contract it has also been associated with the make contract and init contract. Now in the script file we are invoking all the transactions takes place, and as you can see here we are now like giving the ownership here. We store it in a variable, replace it with the new value has been came as a parameter, and then we push it to the network. Here's a new contract has been created, and this is an event that has been emitted whenever the ownership changes. Same happens in the wholesale function, you can see. Same happens in the retail function. And there is an AND contract has been evoked, which takes an init contract as a new relation so as to verify it. Now coming to the next part, here's the temperature reading. It's been pushed, so a new temperature reading comes. Here's an if and else, for example, to check whether if this is the first data that has been pushed or if there is already a data stored in that array. So after this process, the temperature is being pushed into the array. So this is a function how which we create a new package. So this you can see the function has been invoked to this namespace for this asset with this ID. So and these are all the basic essentials given to that, and then it gets pushed into the network. Same is all for all the procedures. For example, if you take the manufacturer, this is a resource, so we create it as a new resource, the namespace, the participant class, and then the ID, and with all the basic essentials been given, and then it gets pushed into the network. Same for the shipper, same for the wholesale person, and then same for the retailer. So now we are showing you the minimum viable product, which we call it as a smart temperature box. So in the smart temperature box, as you can see, there are two partitions. The first partition holds the medicines or vaccines, and the other partition holds the ice packs, which we call it. We store all the ice there, and this whole box is thermally insulated. Here's the partition, and that groove is what we call a flap. That flap opens whenever RPI tells him to do so via script, and this whole box is thermally insulated. So when the flap opens, the cold air comes from this partition to the medicine partition, and it tries to regulate the temperature to the desired value. So in this manner, this box regulates the temperature onto itself without any intervention.